Hey guys, okay, so we're going to take a look at section 4.4. 4.4 is pretty nice actually because it actually kind of gives us some quote unquote real world application for using quadratic equations. All right, so for using parabolas and stuff. So let's take a look at what's going on in here. My first one that I want to look at was actually from section 4.3, which is on page 301, it's number 86. And let me read off kind of how this works. What it's talking about is there's a company, and this company, in this case, it's the John Deere company. But what's going on is it talks about their how much money they're going to make depending on how much they charge for a certain product. So in this case, they're talking about like a riding lawnmower. And so it looks something like this. Let's say we have our XY axis, so like this and like this. So across the bottom, we'll put the price of how much they decide to charge for this particular lawnmower. And then across the top, we're going to put their profit, how much money they would stand to make if they sold it at that price. In the book, it calls it their revenue. The revenue is the amount of money they make plus a bunch of other stuff. But so let's do, this is their revenue. Okay, so we have the price going this way and the revenue going here, and it goes like this. If they sell the lawnmower for a very, very cheap price, so way down here at the bottom, if they sell it for a very cheap price, they won't stand to make a lot of money because they're gonna sell it really cheap. They might lose money on each one, so they're not gonna make all that much money. So if they sell at a very, very cheap price, they're not gonna make as much. So it looks something like this. Now, so where X is like the price, so here they're charging like $5 for this lawnmower. Well, that means they lose a whole bunch of money each time they sell one. So even if they sell lots of them, they're not going to actually, at the end of the day, make all that much money. The more they charge for it, though, they charge a bunch, they end up charging a whole bunch of money for it, they're going to make a whole bunch more money. Now, there will come a point, though, where at some point they're going to charge the right amount of money where some people are going to say, you know what, that's too much, I'm going to not sell them anymore. Or, I'm not going to buy one anymore. And so there's going to be a place where it's going to kind of max out. There's going to be a spot where it's going to even out. And okay, so at some point they're going to charge a certain price, and people are going to say, okay, that's about as high as I'll go, and I'll still buy it. And some people are going to stop buying it altogether. But if they go beyond that price, if they charge more than that, people are going to say, you know what, I can cut my grass some other way, I'm going to go to some other company. And they're actually going to start losing money because they're going to charge all this money and they're going to sell fewer of them. And so the more and more they charge, the less they're going to sell. And so they end up with a shape that looks something like this. It's a parabola that goes down. And as the price increases, this is how much money they're going to make off of it. And so we end up having this kind of a shape. There's a magical place right here at the very top of this parabola. It's a downward facing parabola. There's this magical place up here where this price right here, this X value right here, this is the price that if they charge that much, they will make the most money that they'll ever be able to make. They will maximize their revenue if they charge this much money for each lawnmower. So they won't be losing money on each lawnmower because they're charging too little. And then they also won't be charging so much that nobody buys them. They'll be right balanced in the middle. Now if you remember the maximum point of a parabola that faces down, well, that was the vertex. So this right here is the vertex of this parabola. If we knew the coordinates of this vertex, we could figure out, well, what's the magical price that they have to charge, and how much money would they make if they charge that? So if we knew the vertex, that we would get an XY value. The X value for that would be how far over we go, so that would be the price that we have to charge for the lawnmower. And the Y value, how far up we go, that would be our revenue, how much money the company is going to make for selling it at this price. Okay? So all we really need is the equation for this graph, for this parabola, and there's in the company there's departments that do nothing but analyze all the data, and they figure out what that price is, and they give it to us here. So this is the equation that models this parabola. All right, so their revenue curve. So this is, they give it to us R of P. So where R is the revenue and P is the price they sell per lawnmower. So if they decide, so whatever price they decide to sell the lawnmower at, we plug it in here, and then the number that comes out will be the revenue they make for it. The X value is like the P, and the Y value is like the R right here. Okay. Okay, so what we have to do is to find the vertex of this thing. Well, how do we do that? If you remember, we can find the X value of the vertex from right here. I'm going to rewrite this down here so I have more space. But so we get R of P equals negative 1/2 P squared plus 1900 P. There we go. So what we have to do now is find the vertex. If we can find the vertex, then we can figure out the magical place of how much money they have to charge for each one and how much money they'll make when they charge that much for each. So let's see what happens here. So let's plug. So if you remember how to find the vertex, we can find the X value of the vertex, and that's with negative b over 2a. So let's do that. That would be this is the a, this is the b. So that would be negative 1900 over 2 times negative 1/2. So that would be negative 1900 over negative 1, and that'd be 1900. So that's the X value of our vertex. That's the price they have to charge for this riding lawnmower. This is 1900. If they charge $1,900 for each lawnmower, it's a riding lawnmower, so it's a little bit more fancy. If they charge that much money for each lawnmower, then that will maximize their revenue, maximize their profits. But so that's good. But so now what is that profit though? When they do that, what is the profit they're going to make? To figure that out, we can take this X value now and plug it back into the function. And then what the number that we get out will be the Y value of the vertex, which will be the amount of revenue we get. Okay? So we're going to do R of 1900, which is going to be negative 1/2 times 1900 squared plus 1900 times 1900. Lots of 1900s going on. So 1900 squared, I did the math already, and it's $3,610,000 plus this again, 19 times 19 would be the 33,610,000. Okay, so there's that. So we have that going on, lots of big numbers here. This is negative 1/2 times this, so we end up getting negative 1805000 plus 3610000. And then now we just add this together, and it looks like we get the same number back, but it's positive now, so 1805000. So this means that if they charge $1,900 per lawnmower, that will be if they do that, they will make the most money they'll ever be able to make off these lawnmowers, and that amount is this amount right here, the $1,805,000. So John Deere's doing pretty good. But so that would also be the coordinates of this point right here. The vertex here is the point 1900 1805000. That's the point right there, the coordinates for that point. Here we found the X value for the point, and here we found the Y value for the point. Okay, so that's the first kind of model we can use. The other one, the next one here, is a little bit more concrete, but both also using a parabola. So this one kind of addresses one or two of them that are in the homework, and then this next thing will be the other kind. Okay, here we go.